Hello everyone and welcome to episode 2 of the C++ Mastery series. Now, in episode 1, all we really did was print hello world to the screen and that's about it. It was just getting started. Now in this episode, we're going to focus on data types and variables, the different types of ways to store our information in the program. And of course, you can think for yourself why that would be useful. So without further ado, let's get right into it. Alright, so this is similar hello world code to what we left off with in the previous episode, but let me pose a quick scenario to you. Let's say I have a variable called int age and it holds my age, which is 24, and we want to print that out to the console. My age is, and then we will put age right over there, and we build this. Built successfully, we run it, and then you'll see my age is 24. All right, as you can see, I've stored this 24 value in something called a variable, and then I've shown that variable to the console and displayed that for you all to see. And interestingly to note, I'd have to put it in these left stream operators with no quotation marks. Quotation marks are for strings, right? And this is our own variable. This is not a string literal, which we will cover in another video, but for now, let's focus on the variable itself. So the signature is what type it is in the front. It's not like Python where you can put just the name and it will figure it out. You actually have to put the type, and that's what we call a strongly typed language, and C++ is a strongly typed language. So we have the type, an integer, we have age, and 24. But now, integers, right, are typically 32 bits in size, all right? And again, this is not standard because one thing you'll know is that the C++ standard does not say what size variables shall be or data types shall be. It's just a general outline that most of the time on most operating systems, it will be 32 bits. So don't take that as the be all and end all. But in our case, it's 32 bits, okay? And this is 4 bytes because there are 8 bits in 1 byte, right? And because it is an integer, integers are signed, so it can represent negative and positive values. So how many values can we represent? Well, since it is 32 bits, it is 2 to the power of 32. And if we pull out our calculator, 2 to the power of 2, no, I don't have the scientific one out, 2 power of 32. It's pretty big number, right? But that's the range that we can represent. We can actually only represent if we divide by 2 and then, or minus 1 divided by 2, whatever. Roughly, we can represent 2 million positive values and 2 million negative values. That is the range that we can represent. But you may be asking yourself, wait a second, age is never negative, so why on earth are we doing this to ourselves? Well, we have a thing called an unsigned integer. All right, all integer types have a signed version and an unsigned. And the unsigned just means that it will never be negative, right? So now we can represent 4 million positive values instead of the 2 million positive and 2 million negative. So we have a much larger range of negative or positive values that we can represent. And in cases where it's always going to be positive, you want to use an unsigned version because you can just represent more with less, right? It's kind of obvious, okay? So that is integers. Now, obviously, this int, as we said, is 32 bits in size. But if you actually include the cstdint library, I believe, then you will see stdint. You will get a bunch of different things here. One of them is an 8T, 64T, 32T, 16T, and these are all sizes in bits. So if I write this, these two are equivalent. Look what I've done. These two are equivalent in size, right? Because they're both 32 bits in size. However, the one on line 7 guarantees that age will always be 32 bits, Remember how I said int is implementation defined, it can vary on depending on what system you're using. These are always a set size, and so these set with integers or data types should always be used instead of this integer, right? Not a lot of people go over that, but that's the better practice, all right? And we can use, let's say, 8. This is now an 8-bit integer, and we can represent 2 to the power of 8 variable, range of data. We have 16, we have 32, and we have 64. Then, if you put a U in front, we have the unsigned versions. U64, U32, U16, and U8, all right? Now, let's go over some more data types. We will leave this one as a uint, sorry, my brain died for a second, uint 8. And for age, this is a very logical choice because obviously the max size for unsigned int is 2 to the power of 8, which is 255, right? And no one's going to be older than 255 years. That's kind of obvious, no? But let me show you something else, right? If we hover over this 24, you may notice that in brackets, it says int. But why is that? We've written it as an unsigned int. Well, if we just write a number like this, this is what's called a literal. When I said these are string literals, it's literally just the data type right there. It's not stored in a variable. That's what the term literal means. And a literal written just like this, like a number, actually has the default type of int. So what's happening here is it's casting it to an unsigned int and then saving that as the variable. So usually when you work with unsigned, it's better practice to put a U at the end. That now makes this an unsigned literal. And if I hover over it, you will see it's unsigned int. Now, of course, it must still go to uint 8, right? So what happens if, for example, this now is unsigned int. So this is 2 to the power of 32 range, and it can represent a lot more than uint 8. The maximum for uint 8 was 255. What happens if we type something like this? Sorry, obviously that can still be represented. Something like this, 256, 1 over. What happens then? Because this is an unsigned int, this is a valid literal, but it's being stored as a uint 8. And the maximum for uint 8 is 255. What happens now is what we call wrapping, okay? The integer will actually wrap around. So this maximum is 255. So if we take our current unsigned int minus the maximum, it will be 256 minus 255 equals 1. So our value in our variable right over here will actually be 1 because it will wrap around, all right? This will continue going for massive numbers like this. It will just keep wrapping until eventually, you get to the value. And you won't get any error like that. Maybe if you have warnings on, but it's valid C++ to write that, the wrapping behavior. So that's just something to be aware of now. Let's go back to my age actually being 24. Let's go over some more data types now. We went over signed and unsigned. Some other data types that we have are floats. All right. And a float could be something like, let's say house width, I don't know, something ridiculous, right? And then it's like 123.86, okay? Now, if you're not familiar with floats, float just stands for a floating point number. And what does that exactly mean? Well, the floating point number indicates that the float moves, right? Oh, sorry, that was wrong. It indicates that the decimal floats, right? This decimal over here can float around in our value. And the maximum size or number of digits, that a float can hold is around 7 digits usually, okay? What does this mean? Well, let's say I have the value 12345.6789, yeah, something like this, right? Let's say I have a floating point like this. Well, we know the maximum digits that can be held in a float is 7. So we count 1, 2, 3, 4, 5. Don't count the decimal. 6, 7. and then the 89 will get thrown away. All right, this is what it means by the decimal floats around, you know, cutting off depending on the value. Likewise, it could represent something like this, okay? And if you have a very big value, it could only represent something like this, or maybe even something like this. Okay, so the decimal can float around depending on what precision you need. That is what a float is. And the sort of standard, you know, widely used size for a float is 32 bits, which is 4 bytes, same as an integer, okay? Now, again, this is not always the case, okay? It's just, you know, the standard that's mostly used. Now, if we hover over this, you might see that it says double. Now, double is another data type that we'll get to in a second, but again, this literal, anytime we write a number literal as a decimal like this, it gets the value of a double, and we actually want a float. So always with floats, what you should do is, again, at the end, put an F. That says that this is now a floating point literal, as you see, and we are storing it as float. A lot of people don't do that and make that mistake early on, so it's good to get in the habit of writing U's and floats and knowing when to write them. That's the important part, right? Now, obviously, we're a bit restrictive with our floats. What if we want to store a pretty big decimal number? Well, that's where we have doubles. Let's say pavement, I don't know, we'll stick with our house theme. Pavement area is equal to something like this. Maybe that's a little bit too big, but yeah, maybe something like this, right? This is obviously more than 7 digits, okay? And it's a lot more precise. And now we don't need the F at the end because this literal is already a double literal, okay? Now, the name double comes from the fact that the float is 32 bits, the double is 64 bits, okay? So 8 bytes. And it's also that the precision in float is roughly 7 digits, whereas the precision in double is roughly double. It's like 15 digits, somewhere around there. So if we count 1, 2, 3, 4, 5, 6, 7, skip the decimal, 8, 9, 10, 11, 12, 13, 14, 15. So most of the time this 3 is going to get cut away. This is still pretty good precision, as you can imagine, okay? Now, one thing that we haven't shown yet is, let's now imagine a scenario where you're a bank and you want to store the bank balance for people, right? Or you're a stock market and you want to store the prices of stocks for people. You may want to store it as a double because obviously, you know, this could be the value in the front. You could have this amount of money and this amount of cents, right? That makes sense logically. But let me show you something interesting. Okay, let's imagine we have the double of 0.1, the pavement area, and we now want to print out this, you know, let's get rid of that whole age thing, we don't care about that anymore, and we build this, build successfully, and we run it. We get that our pavement area is 0.1. okay, that's actually a little bit unexpected because honestly, let's see what happens if it's float, but this is bad for my point right over here. And it's storing as 0.1. Okay, I couldn't display what I wanted to, but honestly, the thing is that with floats and doubles that they cannot store decimal values like usually 0.1. It may be that the compiler is doing some rounding and figuring it out, but I also think that this is not scientific output, so it's probably rounding it for cout. But the reality is that double and float cannot properly store these decimal values because they're storing it in binary, ones and zeros, right? And you will end up getting rounding. Usually now in your program, you will not see 0.1. If you have like scientific notation on or whatever, you'll see something like this, right? It can't really store that 0.1. It's likewise, you know, you can think of some other values, but that means that there will always be some error, and that really can't happen with money. And if you've ever noticed on the stock market and for banks, in the back end, they will store your value as integers, right? Unsigned integers in cents. So let's say I have the value of, $100. Oh, sorry. Let's just make it $10 and I don't know 50 cents or something, right? They will convert this into an unsigned integer over here with some name, and they will then, I don't know what this is, and I don't know, I think there's 100 cents. I don't know, whatever, but you get the point, right? They'll convert this into cents. Let's just say it's 105 cents, right? Just or whatever, or 1050, I don't know. Then they will rather store this instead of the decimal point, because this has much higher precision than this ever will have, because computers of course will round the decimal points. Just always remember that if you're working with money, store it in cents rather, and that's the reason for it. Okay, now we obviously print it out to the console, and we will get into later why this is able to even work with this funny stream operator and this bunch of things that are popping up. Don't worry about that now. Another thing is that variables, in the name it's variable, it can change. So I can now all of a sudden be 25 years old, and if we run this, you will see, did it build correctly? Out. Let's see. Let me just check again here. Build finished. It's not printing. Am I missing something? Let's see. Maybe can't see it. My age is. Sorry for that. My age is, and it's not printing. Oh, well, that was actually a trick on you guys, okay? Why is this not printing? Well, it's mainly due to the fact that uint8, it's mainly due to the fact that the variable is a uint8. It is an 8-bit type. And that brings us to our final data type. Well, it's not all the data types, but it's the final common one. And that is a char. One character. A equals I, something like that, right? This is the char literal, by the way. These single quotes are char literals. If you hover over the double quotes, you will see that this doesn't work, because this now is a const char array, not a char literal. Okay, so single quotes is for char, and a const char array is just an array of chars with a null terminating character at the end. I'm sure we'll get into that in a later video, but for now, this is how you write a char literal. And chars are 8 bits, which is 1 byte. Okay, and you may notice 8 bits. This is also 8 bits, and chars are also unsigned 8 bits, right? Because each character here is represented by a certain number, 105, for example. Okay, and this is a printable character to the console, right? So when we say my age is and then give our age, we're actually printing the printable character for 24. And that looks like it's, I don't know, nothing. Oh, sorry, we're actually printing 25. This over here is 105. So let's say we print 105 instead for age. And now we print it. My age is right at the bottom. We get my age is I. Exactly what we did over here. Isn't that cool, right? You can do some nice Unicode characters like smiley faces and stuff, but whatever. We actually want our age to print, we want our real age. So let's say again we're 25. What do we do? Well, it turns out that only the uint8 is the one that behaves in this strange way. So what you can do is you can quickly cast it, and we're going to use C-style casts for now. I'm not going to go into too much detail because look what I'm doing. I'm not going to go into too much details with this now because this will come in a later video. But we're basically just casting this back to a regular int. Now, if we build and we run, you will see now that my age is 25, the correct value that we expect. So yeah, you can't print out the uint8 variables unless you expect them or you want them to convert to chars. Now, one last thing before we end the video is to go over const. Now, variables can be made const and then they cannot change at a later date. We're just skimming over this right now. You can put the const in the beginning or after the type of the variable. It does not matter. For me, I prefer to put it after the type. All right. And I think that is the end of our data type video. If you enjoyed it, please stay tuned, like, comment, subscribe, whatever. We're going to go through the whole C++ syllabus pretty much from beginning to end. I know a lot of YouTubers do that, but they don't go over the really advanced stuff, which is what we're going to touch on. And I think that is going to be really unique and a good learning experience for you guys. So definitely stay tuned if you want to watch that. If you have any questions related to the video or C++ in general, or just programming in general, you know, it could be anything. Put it down in the comments below and I'll reply to it as soon as I can. Thank you for watching.